Okay, so we are going to do what's called finding a particular solution. Okay? And when I ask you to find a particular solution, I'm essentially asking you to find what is the plus C. Alright? So we're still going to do our antiderivatives the same as we've done for the past couple days. But I'm going to give you an additional piece of information about F that would allow you to specifically find the function that has that particular coordinate. Okay? So I'm going to give you, here's a derivative, here's a coordinate on the function, find me the function. Okay? For example, I'm giving you information that f prime is 4x squared and f of negative 3, f of negative 1 equals 3. Okay, so one thing at a time. Let's take f prime and go backwards to function f. So if we want function f, we know that that is going to be the antiderivative of f prime. Would you agree? We have to take our derivative and go backwards. Max, what would that make f of x? Good. Plus C. Important today. Okay. Because now, if we know that we have the coordinate negative 1, 3 on our function, we can determine what that plus C is. So at this point, we can say, all right, well, if we plug negative 1 in for x, our function value, 73. So this would mean 3 is negative 4/3 plus C. And C would equal 13/3. So our function would be 4/3 x cubed plus the particular C we found for the given coordinate. We know one coordinate on that function, we can determine the exact equation without that arbitrary plus. Kind of interesting. All right. I'm going to give you one to try. Work on it and compare answers at your table. That is a 4. Okay. Trent is putting up his work. All right. This is the work representing Pod 6. Do you agree with Pod 6 work? Yeah?
Yes.
All right. Cool. Now, what if I said find G if G double prime is sine of x? What sort of information would I need to give you in order for us to be able to get there? Okay, so 2 points, one where? On the derivative, and one, okay. So I better give you some information about a coordinate on the derivative. What did I come up with here? And some information about a coordinate on the actual function itself. Okay. Now it doesn't always have to be at the same place. That's what's happening here, but it doesn't have to be. Okay. All right. So we have to do this one level at a time. If we are starting with G double prime, our first level is to get to the first derivative. All right. So our first derivative is going to be the antiderivative of the second derivative. What is the antiderivative of sine of x? Negative cosine of x plus c. So then we can come up here. You can say, all right, well, we know that when we plug in 0, our output should be 1. What's the cosine of 0? All right, so that makes our C value 2. So we know that g prime of x is negative cosine of x plus 2. Okay, now we need to go one more time around. So we want to get to g of x, which means now we need to take the antiderivative of g prime. Now be careful with your notation, okay? I'm putting that in parentheses so we know we're taking the antiderivative of it all together. And please do not forget about the dx, okay? Please get into a habit now of writing that dx because come unit, does it come next? Like unit 5? Like I'm going to take off 22, set up the integral again. All right, so the antiderivative for negative cosine, what kind of sign? Okay, it has to stay negative. And then the antiderivative for 2 would be 2x. Plus. Okay, back up top, we know that g of 0 equals 6. So we can go ahead and throw 6 over here. Throw 0 in for x. And this is nice because the sign of 0 is 0. So C is 6. So we have g of x equals negative sine of x plus 2x. Okay. I want you to look at your gold sheet real fast for me.